Now the figure below shows an object suspended from two ropes. The weight of the object is 360 newtons. The magnitude of the tension in each rope is T, as you can able to see on the diagram and from the demonstration on the other side. Now this tension in the rope is making 45 degrees with the horizontal the object at this particular point here. So in the space below, determine the tension T by drawing a vector diagram of the forces acting on the object. State the scale you have used. Now I recommend, before you start anything, see if you can able to make a sketch of what can work for you. So if we have this, because this is actually going to be the long one, this has the force that is acting downward. Of course it's acting downward. You can see this is acting at an angle. So if I draw something like this to show the tension, this T1 here, then this you can see it is acting, at this particular point. So we are having this acting in this direction. So if you can able to draw this, and then look at this, the angle with the horizontal. So if you're supposed to sketch horizontal here, this is 45 degrees, and then this one also, this anytime you draw this line, because it will be parallel to this will be 45. So it means if you sketch something like this is 45 degrees. So this is 45 and this is 45 degrees. So but we have this which is 360 degrees. That is what we start with. Now we can choose a scale which can actually fit here. So I can decide to rotate the diagram such that this part become the base, but there's no need. So what we'll do, we'll need to choose a scale. The scale you're choosing should be able to fit the space that you've been given. There's enough space here. For this, I would prefer us to use 1 centimeter to represent 50 newtons. So 50 newtons, that means for 360 newtons, we will be able to just take 360 divided by 50. This will be 7.2 centimeters. So for 360, we'll be able to draw 7.2 centimeter. So we measure. It can be very easy to rotate this so that we have the base, but for now let's just draw it the way exactly it is. Then there's this 45 degrees, as you can able to see. So we're just going to measure 45 degrees from this particular point exactly at the head. To the head of the arrow. So we measure 45 degrees from the sketch, 45 degrees. Let's do 45 degrees. Remember the arrow, the tension, this is what we're talking about, is acting in this direction. So that means tension T, within the T that is acting. So we can put the arrow here, but anyway, it's just to show the direction in which the tension is acting. So we have our T. This should actually be equal to this because this forms like a isosceles triangle. So if this is 45 degrees, this is 45 degrees, then the length from here to here should be equal to here to here. Let's confirm. This is about 5.1. That is 5.1, correct? So remember, we are using the scale 1 centimeter to represent 50 newtons. So if 1 centimeter represent 50 newtons, what about 5.1 centimeter will be equal to what? So that is 5.1 centimeter times 50 newtons divided by 1 centimeter. The centimeter cancels centimeter, so we have 5.1 times 50, so that will be 255 newtons into two significant figures. This will be 260 newtons. So 260 newtons. Now you can confirm this from the marking scheme. This is February, March 2019 for 2. 2019 for 2. I think it's question number 3 to be the question. So you can confirm that indeed the tension is 260 newtons.